All right, welcome. It's great to see so many of you over here. I'm certainly excited, but welcome to what's new in EC2. So my name is Willem Visser. I am a VP for running AWS EC2. And my career at AWS started more than 10 years ago in a city called Cape Town in South Africa. And at the time, I joined the team and they told me we're building the Elastic Compute Cloud service. And that service, of course, now these days is known as EC2. Creating EC2 10 plus years ago required us reimagining how compute was done. And today, in response to what our customers asked from us, we continue to reimagine how the cloud functions. When we first introduced cloud computing, we had two main goals, which continue to drive what AWS delivers today. The first one, pretty simple, provide customers with tools and services to securely and reliably run virtually any workload in the cloud. The second, equally as important, is delivering customers more performance at a lower cost in the cloud. Now, when AWS started, we had a single region in Northern Virginia. Today, we have 34 regions worldwide, and we're busy building another 6. We have 108 availability zones, and we also offer 41 local zones. And all of that, we serve 245 countries and territories globally. And we obviously continue to build that out. I love statistics. That amount, 51 billion, that is how many EC2 instances we launched in 2023. Now, in 2024, we're obviously already way beyond that number, more than tens of billions of instances in that number. So when we first introduced EC2 in 2006, we had one instance, the M1 instance. We had only one instance type in 2006. And as we respond to customer needs, we continue to add more instance types to allow our customers to migrate every workload they want to into the cloud. Now, AWS is the place where customers continue to come for the best technological innovation. And we've continued to deliver the new advances required to meet every evolving needs. So if you look at the slide, we were the first cloud provider to introduce Intel-based instances into the cloud. We were also the first provider to introduce AMD-based instances in the cloud. And you can probably see where this slide is going, right? We're the only cloud provider that actually provide Apple in the cloud. And of course, we've got our own Graviton processors. And I know that you all believe that GPUs are omnipresent, but we were actually also the first cloud provider to work with NVIDIA and bring NVIDIA processors to the cloud. So back when we launched in 2006, our first instance was a 1.7 gigahertz Xeon processor with 1.75 gigabytes of RAM, right? It's hard to imagine that far ago that's what we had. It had 106 gigabytes of local disk, spinning disk, and 250 megabits a second of networking bandwidth. And then I don't know how many of you know or can guess, but we built 10 cents an hour for that instance. So after introducing that initial instance, we started to realize that many workloads required different characteristics. And it would necessitate us to introduce more compute or memory-optimized instances over time. So we can't have this talk without actually mentioning or going through Nitro. So Nitro has grown into a core component of EC2, offloading our virtualization functions to dedicated hardware and software. It has been a key to unlock many EC2 innovations over the last number of years. In the early days of AWS, The idea that virtualized compute instances could be rented by the hour, accessed over the internet, was unheard of. And in actual fact, many folks told us it's impossible or it's not going to work. Multi-tenancy through virtualization has become a force of disruption that is still evolving today. As we grow Amazon EC2, we faced many challenges. Like, remember, I spoke about doing EC2 in the early days. So in those early days, we faced many challenges with our software-based hypervisors. And looking back at that era, all Xen-based, we incurred notably CPU and memory overhead. And this overhead greatly impacted the overall price performance of virtual machines. We spent years optimizing the hypervisor layer, but our progress was linear, right? We made great progress, but it stayed linear. And we knew this would not be enough to keep up with our customers' ever-evolving workloads. And they were evolving quickly, both in size and complexity. So from all of this, AWS Nitro was born. At the lowest level, the Nitro system has Nitro cards, and those cards offer networking and storage and security functionality. In the host, we run our Nitro hypervisor, and on top of that, your virtual machines and applications. So with Nitro, AWS is able to offer a better overall security and encryption posture. We allow secure boots, and we give restricted access. When we launched the Nitro system in 2007, we delivered a unique architecture that restricts any operator access to customer data. And this is super important. So what that means is no person or even a service from AWS can access data when it's being used in an Amazon EC2 instance. That is the promise of Nitro. So consider all of the recent headlines about security vulnerabilities in millions of commercial chips. At AWS, security is job zero. The Nitro security chip protects the server from unauthorized modifications by continuously monitoring and verifying both the instance hardware as well as the firmware. In 2023, the NCC Group, a leading cybersecurity consultant, validated that the Nitro system has no mechanism for anybody, external or internal to AWS, to access customer workloads in EC2. So over the years, we've introduced 5 generations of the Nitro system architecture. And each subsequent generation, as you can see on the slide, improves on both, many important dimensions: lower latency, higher throughput, the ability to handle more packets per second. So our commitment to innovation continues. After delivering 5 generations of Nitro cards today, I'm very proud to announce the 6th generation of Nitro cards, Nitro V6. So this latest iteration unlocks unprecedented performance, scale, and functionality in the cloud, enabling over 400 gigabits of throughputs in a single card. This represents our commitment to providing additional networking and bandwidth speed that our customers require. With Nitro V6, we improve both performance and security. And so as our customers deploy clusters of accelerator-based instances to train and fine-tune large workloads, they want to be able to feed data at a very high throughput to ensure those instances are running at high utilization. That is why I'm also excited to announce our new C8GN instance, powered by Nitro V6 and our Graviton 4 processors. With C8GN, customers can ingest, process, and feed data at high, incredibly throughput from S3 or data lakes, scaling performance and throughput while optimizing costs. C8GN instances also are well-suited to implement high-performance file systems, such as Lustre, the most popular file system used, I'm sure, by many of you as well. So CAGN instances deliver up to 400 gigabits per second network bandwidth and up to twice the amount of packet processing performance versus existing network-optimized instances. So there's so much more that we're doing to support all of your workloads, from AI to all of the other ones as well. So we continue to partner very close with our customers to drive innovation across all of our instance portfolio. I want to, again, same as Nitro, I actually want to give a brief overview again of Graviton as well, which I'm sure, hopefully, most of you are familiar with. So Graviton is our general purpose processor designed by AWS to give you the best price performance. In EC2, it uses the ARM instruction set, and we created Graviton because we knew we wanted to provide the better price performance in the cloud. And in order to do that, we needed to design a processor that is made for the cloud and optimized for cloud workloads. So this is an impressive slide, and those of you that have seen some of the keynotes from Dave would have seen this as well. So this is very, very exciting. So over the last 2 years, more than 50% of new CPU capacity landed in our data centers was, in actual fact, on AWS Graviton. So that shows the incredible adoption from our customers and how popular Graviton actually is. So that number means it is more than all the other processor types combined that we've landed. So earlier this year, we landed Graviton 4, our most powerful processor to date. And not only is it the most powerful, it is also the most energy efficient processor that we've had. So Graviton uses up to 60% less energy than the other chips that we have in our data centers. And customers such as Zendesk have used AWS Graviton instances to deliver over 40% reduction in their 50% reduction in their monthly carbon emissions. So I want to talk about benchmarks as well, because I'm sure many of you have used benchmarks in the past and are pouring energy on benchmarks. So today, most chip designers work backwards from micro benchmarks tests to motivate how they design and how they improve their chips, because these benchmarks are well understood. But micro benchmarks are not real workloads, right? So they're not real worlds. And as it turns out, they're quite different. And the mismatch means that the hardware is being designed against a set of goalposts that won't translate to optimal performance in production. It's a bit like studying for a test and getting ready for that test in school, and then realizing there is much more to understand to really achieve mastery for that test. So to help us visualize benchmarks, we're going to use a radar graph. And a single point on this graph can give us a holistic view of a given workload's characteristics. So each axis corresponds to a different chip design trait, with a value corresponding to that workload's sensitivity towards that trait in determining its overall performance. So processors can be thought of having two halves. So the front half, as you can see over there, receives instructions. And its performance is influenced by factors like number of branches, branch targets, instructions, and all of these ultimately can result in front-end stalls. On the other side, the back half executes the instructions and is sensitive to properties like data in the L1 and L2 and L3 caches, and the instruction window size, and all of these ultimately can result in back-end stalls. So plotting front-end statistics on the left and the back-end on the right, this allows us to see at a glance where the workload skews towards the front end or the back end. The higher the value, the more relevant the property is to performance. Smaller is better. So what can these graphs teach us? So let's start with the benchmarks. That is sort of traditional. So in the traditional benchmark test that you can see over here, you can actually see it stretching the L3 cache with a large number of back-end stalls. right? So remember we spoke about those two halves. And so this tells us that generally the back end of the CPU pipeline isn't able to find enough work to do. So while we see sensitivity on the right side of the graph, we don't see much on the left-hand side. So when you step back to think about it, it kind of like makes sense. Most benchmarks are small kernels that has been extracted, and they do the same thing over and over again, right? Essentially in a loop, repetitive. So these traits make them very easy to analyze, makes them easy to understand, but it doesn't have a lot of variety in the instructions. And there aren't a lot of branches beyond very simple loops. So how does this compare to real workloads? So here we have Cassandra, Groovy, and Nginx, a mix of common customer workloads that we see customers running on AWS. So when we compare these real-world workloads to the same benchmarks, we can see that they're bottlenecked on an entirely different set of factors. Particularly, these workloads are impacted by things the other micro-benchmarks didn't care about. So the branch predictor is missing more. There are lots of instruction missings out of the L1 and L2 caches. The TLB misses. So unlike the benchmarks that we just saw, the front end is causing the stalling. So all of this sums up to the front-end stalls being higher and not the back-end stalls that we saw in the previous benchmark. So when we analyze a real-world workload like MySQL running on Graviton 3 and Graviton 4, as you can see on this slide, we see lower sensitivity across all dimensions. And so remember, smaller is better. So this results in improved performance on our MySQL workload here, allowing Graviton to do more work on the same number of CPUs. So customers typically see a 40% performance improvement over Graviton 3 when running MySQL, a real-life workload. So if we take a look at Graviton 4, each Graviton 4 CPU has 50% more cores. And it's got twice the L2 cache compared to Graviton 3. So Graviton 4 will enable instances to scale up to 3 times more CPUs and 3 times more memory than the previous generation to support your highest performance databases, in-memory caches, and big data analytics workloads. So in addition to optimizing performance for your real-world workloads, Graviton 4 also raises the bar on security by validating and monitoring and protecting every stage of the host boot process. We have actually fully encrypted all of the high-speed hardware interfaces that goes from DRAM, all the Nitro cards, and all the coherent links between the CPUs. So in 2024, we made generally available an entire family of 4th-generation instances, and hopefully some of you have seen them and used them, so it should be familiar to you. So CHD, RHD, MHD instances. These are our most powerful processors so far. I spoke earlier about the additional cores and caches along with more memory bandwidth. All of this translates to 30% more compute performance than our prior generation processors. So 3 times more memory handling, which enables high-performance database usage. And don't forget, as I mentioned earlier, more energy efficient. So we've recognized that many of our customers could benefit by knowing more so that you can start saving more. And in actual fact, I had multiple conversations this week about customers wanting to find out when should they migrate, where should they move to, how do they know, where do they go and have a look in order to have and make the decision. So I want to introduce the AWS Savings Dashboard, which is easily accessible and allows you to gain insights into your current Graviton usage. The Graviton Savings Dashboard offers a comprehensive list of things that gives you insight into your workloads. It provides guidance and advice on migrations, and ultimately it gives you a picture on the potential savings that you could actually go and realize, your total cost of ownership. And as we think about how to manage instance selection, performance, and ensure resilience for your cloud-based applications, I thought it would be best that we would hear from a customer. This customer constantly manages the cloud's ecosystems. And so with that, I'd really like to welcome Ed Peters, VP and Distinguished Engineer from Capital One, to tell us more. Ed, welcome.
Thanks so much. Hi, everybody. As Will mentioned, I'm a distinguished engineer at Capital One. I've been with the company for about 4 years. Prior to coming to Capital One, I was also the CTO and chief architect of some small and mid-sized software companies. And I mentioned that for a specific reason, which I'll get into in a couple minutes. But the topic of my little section of this talk is not strictly focused on EC2. It's really about choice. If you've listened at all during this week, whether it's to Willem today, Swami earlier, Matt yesterday, Amazon's constantly innovating and introducing new instance types, new chip families, new networking and storage options, new models. They are lunatics and they cannot be stopped. And what that means for us as their customers is we face this bewildering array of choices. What do we build on? And we also face the question of, later on, how do we come back to those decisions and feel confident that we made the right ones for our business and for our applications? So I want to talk a little bit about how Capital One has approached that question. In terms of an agenda, I'm going to talk a little bit about our cloud history, how we thought about adopting the cloud in the first place, and the role our cloud evolution team plays in ensuring that we're making good decisions in the cloud. I want to talk about our technical and organizational learnings, about how we've driven that good distributed decision making. And I'm going to talk a little bit about how we cope with this in the face of this evolution. I had a finale planned with some fireworks and a tiger and a gold-plated motorcycle, but Willem and Art rejected that. So at the end, I'm probably just going to trail off and wander off stage. But hopefully the meat of the content will be good for you all. When Capital One made the decision in 2016 to move fully to the cloud, we did it with a couple of things in mind. First, we knew we would get some key operational wins in terms of things like cost and scalability and stability. But we also knew that we were going to empower a team of developers that was rapidly growing at the time. We really wanted the developers to be able to take ownership of the solutions that they were building and make the right choices to build systems and products that would delight our customers and make our customers more successful. Now, we're a bank. There are always going to be rules, and my Capital One sistren and brethren in the audience can attest that we do have rules. But underlying the move to the cloud were a couple of key principles. One was you build it, you own it, which I think a lot of us are familiar with. The idea that by giving developers operational responsibility for the systems they make, that will push them into making better decisions because they want to sleep at night and they want to make the good decisions that enable them to do that. Another principle was this idea of buffet rules. So we want developers to be able to take and have access to the cloud resources they need to make their solution successful. But we also want to make sure that they're utilizing what they take. They're making those decisions wisely, and they're investing the company's resources effectively. Our cloud evolution team plays a really key role in ensuring that we're doing that enterprise-wide. They operate our FinOps practice, which for a lot of companies may sound like simply a cost reduction organization, but it really is about how we ensure that we're making good decisions in a distributed manner. A couple of the things that they do kind of divided into buckets. One, they're responsible for our long horizon capacity planning. They conduct annual and longer term capacity planning initiatives. They handle reserved instance purchases, things like that. I'm not going to talk too much about that kind of global fleet management here today. Instead, what I'll talk about is the other two bullets. They offer a lot of information in self-service tooling for our development teams to understand the impact of the decisions that they're making and help them drive better decision making. They also conduct analysis on Capital One's behalf and look into specifically large applications or AWS services we use heavily to identify larger savings opportunities and efficiency opportunities that we can drive enterprise-wide. I want to start by showing a tool that they've built. What you're looking at is OptiCloud. This is an internal tool that the team has built on top of the data that we've collected from AWS, and all developers have access to this. You're looking at the dashboard for a single application that's showing that application's cloud usage. Now, I want to highlight a couple areas of the screen. To start with, if you look at the bottom, this is an EC2-based application. So we've got some fairly granular information about the EC2 instances that power this application. And we're not just looking at, you've got these EC2 instances and here's how much they cost. We're also looking at the utilization. And in this case, OptiCloud has identified that this team has an opportunity. They've allocated large EC2 instances, which is a common practice, but they have the opportunity to right-size them and generate some cost savings because they've allocated instances that are perhaps a little too large. Now, we love white space and good graphical design, so we can't show you the whole page, but if you scroll down, there are stanzas of optimization recommendations about other aspects of their solution. So RDS cluster right sizing, EBS volume usage, DynamoDB usage. We've pushed into serverless in a major way at Capital One, so there are serverless optimization recommendations. And this is an extensible application. So we have platform teams at Capital One that are building stuff like our machine learning feature platform. There are usage decisions and optimizations that teams can apply when they use those platforms, and those platforms have an internal chargeback model. All that data gets fed into OptiCloud as well, so teams have a single pane of glass to look at the decisions that they're making and the impact on their monthly spend. If you look up at the top right, in addition to the monthly spend for the application, which I've blacked out, we don't need to know for this particular application, it varies from application to application, but we also compute a spend efficiency metric. And this is based on a formula that our team's developed, and we're constantly working on tinkering with it. But what it does is it gives us the ability to incentivize every team to think about the decisions they're making. So if your application is costing Capital One $500,000 a month, you have a very strong incentive to pay attention to cost. But if it's costing Capital One $800 a month, you still have the opportunity to make some efficiency gains. And for a team that goes from $800 to $200 a month, that's an impressive gain, and we want to be able to celebrate that with them. And things like the efficiency metric give them the ability to do that. So how do we implement this? There are a few of our technical learnings that I'll present in this section and the next one about the opportunities the cloud gives us to do things like this. I think one of the unsung heroes about the cloud is actually billing. I don't think a lot of people appreciate how transformative cloud billing is. If you look at your AWS bills, they're extraordinarily detailed. They give you line items for micro units of CPU, network, disk usage. It almost looks like your kid got a hold of your credit card and has been making microtransactions in Roblox for months. That data is actually incredibly powerful. We combine that at Capital One. We have a discipline of tagging every cloud resource to an owning development team, an owning application. We use that for governance, but we also can use that as a join key on the billing data. And we have operational telemetry that all of our applications provide for operational support. So metrics, logs, things like that CPU usage, the network usage, disk storage. We can use that join key to generate insights like the ones that you just saw for all of our application teams to be able to understand the impact of the decisions that they're making and the efficiency of the usage of the resources that they've selected. We absolutely could not have done that on-prem. This is something that is powered by the detail and volume of the AWS billing information we get, the resource tagging we have. It's a really cool data problem that our Cloud Evolution team has spent a lot of time working on, and it's very, very powerful for us. Another thing that I think we sometimes get a little wrong is elasticity. We talk about elasticity usually in terms of scale. My application is under heavy load, so I grab some more resources. But the magic of elasticity is you can give those resources back. So a thought experiment, if you were to go to your on-premise data center team and you were to tell them you wanted to procure and configure some very specialized, highly customized and optimized hardware instances so you could test them out and you were going to throw them out in a week, they would probably quit in protest. Right? The cloud gives us the ability to allocate all these new instance types that are being generated and to test them and to generate deep insights for teams that they can use to make the appropriate selection, not just based on fake benchmarks like Willem was talking about, but based on real world use cases. So our Cloud Evolution team is constantly doing that. They're constantly benchmarking new instance types, new chip families to understand what the performance of those looks like on real Capital One workloads. And we've been able to identify, for instance, a common pattern on some teams is to look down the price sheet and say 48 extra large instance. That sounds good to me. I'll take 3 of those. And what we found is that a lot of our applications actually cannot drive that hardware to its peak utilization. They just, between CPU usage, CPU scheduling, memory bandwidth, whatever it is, it's just not an effective hardware selection for them. And we actually have common recommendations to people to say, hey, peak out at about 8 vCPUs and scale your cluster horizontally, because you'll get the best utilization out of your hardware. And again, all the data we're getting helps us support that conclusion, give it to developers, and let them make the best decisions. One of the areas we've stubbed our toes, especially with new instance types, new chip families, is around flexibility. So we really wanted to adopt Graviton early on. We had to work with AWS closely to understand where the pockets of capacity were. AWS does a marvelous job of presenting this illusion of infinite capacity to us, but there are real laws of physics, and so sometimes we have to collaborate with them on these large fleet management discussions. One area we probably could have done a better job in this is for our large fleet applications, like for instance our Jenkins clusters with thousands of nodes, is potentially to be a little more flexible and say, okay, we'll take what instances we can get a hold of. We may be able to run a mixed fleet of instance types, that sort of thing. Cloud Evolution is working with our development pipeline team to embed some of those levers for development teams that can make their applications more flexible to be able to do that and help avoid the dreaded ICE or insufficient capacity errors. AWS is also continually working on supply chain. They're masters at that. And so this is always a challenge with newer instance types, but it's something that as we're trying to ride that front wave of innovation, it's just an issue that we continually want to work on. And finally, GPU hardware is a really interesting beast. We all know the industry-wide challenges in supply chain and GPUs. Capital One's no stranger to that. But one of the things we've discovered as we've looked more heavily at our GPU utilization, we're doing a lot of AI development. We're building our own foundation models, that sort of stuff. One of the things we've noticed is that GPU utilization metrics may not be as good as they seem. High CPU usage is generally well understood, and it's something that's a good signal that your application is very busy. A GPU utilization metric may actually indicate that you're only using a fraction of the cores on a zillion core GPU. And so our team has been working with Intel and AMD and other industry partners to understand metrics off of the silicon and understand better how can we measure the actual utilization of a GPU-based system. And we've been working with our telemetry vendors to make sure that those signals, things like power draw, are actually making it into our pipelines, where we used to traditionally think only about CPU utilization, IOPS, that sort of stuff. We're adding in power metrics in certain circumstances where it makes sense. So we can look at a server and we can say, okay, low CPU utilization, high GPU utilization, but low power draw, that may be a sign of inefficiency in an ML workload. And that's something that's very powerful for us to be able to give our developers, again, this ability to make good decisions at scale. I want to switch from talking about technical learnings to talking a little bit about how to operationalize that in an organization. And I'm going to warn you now, I have an analogy here that I'm going to beat to death live on stage, and I apologize in advance for that. One of the principles behind our Cloud Evolution team is peanut buttering savings across our entire footprint. So we enable development teams to make these optimization decisions by giving them detailed information and recommendations. With our scale, small savings across a large footprint definitely adds up. It really makes a big difference, and we can see some pretty gaudy savings by driving those incremental decisions around the edge. But then you have what I think of as the peanut plants, right? They're slightly more centralized areas of spend that you can focus on to drive efficiency. And a couple of examples, one would be large applications. We can look at large applications that are a large source of cost, and we can work with those teams specifically to optimize. Cloud Evolution reached out to our observability team who runs our giant Splunk cluster, and they looked with them in detail at I/O utilization and the specialized instance types that they'd selected, and they helped drive some major cost savings in the observability platform. Again, you have to temper that with requirements, and so observability is really critical. That's an area where over-provisioning may be useful. So this is all a series of decisions and trade-offs that have to be analyzed and made. But by doing that, our team was able to create some big savings. Another example is AWS services that are heavily used. We use a lot of DynamoDB, and so our team has made some really good progress on understanding DynamoDB utilization, the proliferation of either over-reserved or under-reserved capacity, and been able to put that information in the hands of our teams. Those are examples of the peanut plants, and then kind of bringing it all the way home. The peanut farm is that large-scale, long-horizon, full-fleet optimization work that the team does around capacity planning. This is where I'll go back to a little bit of my background. As the CTO of a small company, I would fight with my CEO over purchases that cost an additional $500 a month. At Capital One, we have a different way of what we think about as significant savings and how we think about driving this. So, for instance, in a situation like Capital One, where you have 10,000 plus developers working in the cloud, peanut buttering savings across that population is very meaningful. And so the investment we put in there is well worth it, and we've reaped that back multiple fold. Working at my startup, where I could throw a rock and hit every developer on my team, peanut butter wasn't as useful there, but we would conduct exercises to look at the key major areas of usage that we had to understand where we might be able to optimize. So the exact techniques that you use depend on the size of the organization and the exact thresholds you use as well. Again, in a startup, An extra $1,000 a month is significant. You're venture funded, you've got to worry about runway, all that stuff. As you scale, you may be thinking more about top line revenue than bottom line. As you scale even further, the numbers that you think of as really significant enough to motivate a dedicated effort, they may change. So this is an area where your mileage definitely varies depending on the size of your organization. I want to leave you with a few thoughts after all of this. The first one is, again, just to underscore, Amazon is constantly evolving our options, both in terms of the hardware we use, the software that sits on it, the managed services that are built out of that software. The cloud gives us an incredible amount of power when it comes to understanding the decisions we've made on top of that platform. Optimizing our usage and making the right decisions requires both upfront and ongoing investments in understanding what's available to you, how you might use it, and then coming back later and finding out how you've used it. And your mileage may vary depending on the size of your organization. At Capital One, we've specialized in this for the size of organization we have. Hopefully some of these learnings have been helpful for you, but you need to take this into your organization and think about your practice and how you can apply it there. With that, I want to turn it over to Art Baudo, who's Principal Product Marketing Manager at Amazon. Thanks very much.
Thank you. Thanks, Ed. So I want to come back to the concept we talked about a little bit earlier, and Willem talked about, and also Ed here, about the amount of selection that we've had here. So as Willem mentioned, in 2006, we had a single instance. Today, we have 850. And to project how fast this has been growing, in 2017, if you were here at a talk at reInvent, I would have told you we had 70 instances, which at that time, we considered a lot. My objective today is to show you some stories about how AWS has disrupted and revolutionized the computing paradigm across the cloud. And I'm going to talk to you about some of the latest features that we've launched at reInvent this year and throughout 2024. But the first thing I want to start with is the naming convention that exists here at AWS for our instances. So a lot of people say, you have 850 instances. How do I actually figure out which instance that I need to use? So this is a representative of an instance we have that was recently launched. Willem mentioned it earlier. This is C7GN extra large. This is the instance type, the full name. And if we break this down, on the right-hand side is our t-shirt size, extra large. That gives you an idea of how many vCPUs you get to memory. And each of the categories have a defined vCPU to memory ratio. So that brings me over to the very far left side here, the series number. So C, this is a compute-optimized instance that we're talking about. So a compute-optimized instance has a memory ratio of 2:1. And then if we increase the extra large to 2XL, both the memory and the vCPU double. And then next to the C is the generation number. In this case, it's the 7th generation processor family. And then the G next to it is representative of the instance type family. In this case, G stands for Graviton. And so we're talking about a compute-optimized instance in the 7th generation using Graviton, and the N is for networking. So even after all of these capabilities, I've talked to a lot of customers over the years at Amazon and saying, look, this is great, this is helpful, but you're not always going to be sitting in the back room at being able to tell me exactly what the names of these instances are. Is there anything you can do to help? So one of the things we launched this year is Amazon EC2 Instance Finder. And this is a new generative AI powered service within the EC2 console that helps you make accurate, quick, and economical decisions about what the instance is and what instance you should potentially launch. It's going to provide a contextual interface within our management console to meet you where you need help. It provides a natural language processing interface and uses Gen AI, and our knowledge about instance families based upon the information that you've put in to be able to give you a recommendation. So now you don't have to worry about analyzing all 27 instance families, generations, sizes, capabilities. You can build on your own understanding. I wanted to show you a little bit of how to do that and how we do that. So I'm going to first show you the generative AI portion of it. So if you go into the EC2 console, and on the right-hand side here, I selected a question here, which I guess on the screen is a little bit harder than I imagined to read, but I asked for a machine learning instance with high performance in the EC2 instance for it to recommend. So there are keywords that I typed in here that help the system generate the answer. So I've provided the information that I want a high-performance instance, I want to do something for machine learning, and what is the instance types or the instance family. So after hitting enter, it provides a series of recommendations to me. And if for some reason you're looking at this and the recommendations don't firmly align, you can restart, get more recommendations based upon more specific information. So the more specific you are, the even better our responses will be to you here. But if you prefer an alternative interface, we also offer in the same console, we actually will give you this interface where you can provide us a little bit more information. It's based upon the same platform as the large language or that I provided before, but this gives you a little bit more discrete information with drop-down menus, kind of at your choice. And finally, we provide the same recommendations, just it's in a little bit of a pop-up format. And the beauty of this, or at least what I think is one of the good things about this, is all this is happening in the console, so you can take immediate action and begin actually launching and trying out the instance directly from the console. So AWS offers a number of different options for customers when you need to look at block storage, including a variety of EC2 instances with attached storage. And while we still offer a few instance options with hard drives, the vast majority of our instances use SSDs. SSDs can do about 1,000 times more read access per second than a standard hard drive, but they also come with some challenges. So everyone in this room, we're all a little bit technical, probably has seen an SSD before. They're usually about 2.5 to 3-inch boxes. And what most people don't realize is there's actually a full-on operating system that is there and operating. In reality, though, many modern SSD systems are running a full Linux-like operation, and they aren't always patched very well, and they require different manufacturers of the SSDs have a different way to do this and different way to monitor it. So as Willem mentioned earlier with the AWS Nitro system, this allowed us the ability to think about this in a different way and to actually design our own SSDs. By designing our own SSDs, it allows us to have a standard way to actually put this patching in place without having to disturb any of our customers who are using this. It allows us to upgrade our software, and it allows us to reduce latency, both our tail latency and latency access. This allows us to improve performance for the system and reduce overall costs. We actually had 2 generations of these SSDs that have been launched, and today I'm excited to talk about our 3rd generation, which has launched. Our 3rd generation SSDs, we have 2 that have launched here at reInvent. First is the i7-IE instance. The i7-IE instance offers the highest local storage density in the cloud. It delivers up to 40% better compute performance and 120 terabytes of NVMe storage. It reduces the latency, 50% I/O latency, and 65% lower storage I/O. That's compared to the prior generation. So this generation over generation reduction in latency is visible here and impacts and enables us to deliver better performance. The second instance on this screen that we also launched is our i8G instance. So this is based upon our Graviton instance. And this Graviton instance, delivers the best possible compute here. So this delivers the best compute when you're looking at the SSD. It delivers 60% better performance than our prior generation and 65% better real-time storage performance as well here. And along with that, we also have reduced, as I said before, the latency here on the lower I/O side. That's not all. So beyond the work we've done, earlier this year, we launched our U7i instance. These U7i instances are based off of the 4th generation Intel Xeon scalable processors, Sapphire Rapids, and are built for scaling up, particularly for in-memory database workloads. A little bit more about these instances. These were the first 32 terabyte instances to be launched in the cloud by any major cloud provider. These instances use DDR5 memory, and as I said, they're 32 terabytes. They offer up to 896 vCPUs and provide an astonishing 135% more compute than our prior generation U-1 instances. They also have 2.5x additional EBS bandwidth versus our U-1 instances. So we've improved on the performance here as well. And these instances are perfect for SAP workloads to be used. But speaking of SAP workloads, we announced just yesterday that we're going a step further here. We're going to be launching soon our U7 INH instances. This is more than just another lot of extra letters. So what is the difference between U7 INH and U7I? U7 INH instances deliver up to 1,920 vCPUs, so double the U7I instances. They're being developed in partnership with HPE, and this is the first time the HPE Compute Scale-Up Server 3200 has actually been available or being made available in the cloud. This is another instance of on-premises workloads being able to migrate over to the cloud. This is a 16-socket system, excuse me. And what that means, this is a 16-socket fully certified SAP instance that's available in the cloud. It has 200 gigabytes per second of bandwidth memory that is available as well. So earlier this year, our CEO, Matt Garman, was at SAP Sapphire, which is their large conference, talking with SAP CEO about the importance of evolving this space. And this is a direct response to that. Our instances are a direct response to that. And we have a quote here from the SAP's Chief Product Officer as well, talking about the usage of this instance. So that's not all. Beyond what we've done, I want to talk briefly about how you make purchases. Ed was talking a little bit earlier about the complexity and the data and information that they get. I want to talk a little bit about what is available and how we do purchasing here. So first is our on-demand instances. On-demand instances are instances that are pay-as-you-go, pay by the second instances. There are no upfront commitments. And this is where most customers start their cloud journey. And many customers actually have started their journey using their own personal credit card, using these instances to get started as well here. So, but once you're ready to make an additional commitment and you have some additional ideas, we offer savings plans. Savings plans require a 1 to 3 year commitment. In exchange for that 1 to 3 year commitment, though, we give you substantial discounts off of the published on-demand prices. One thing, though, about them is they do require 24/7 utilization. So that may not be for all instances that you're running, or maybe only a portion of your fleet would qualify for a savings plan. So what are the other options that we have? We have also pioneered what we call spot instances. Spot instances allow us to give you back extra capacity that we have. And in order to incentivize you, we offer up to 90% discounts off of our on-demand pricing. So you're probably sitting there saying, what's the catch? There is a catch, but it's a small one. What we do is that we tell you that in exchange for this discount, we could reclaim the instance. However, we give you 2 minutes notice to gracefully shut down in the event we have to do that. However, I will say the majority of our customers find that we don't reclaim the instances all that much. But what this means is that when you're doing this, you need to think about the type of workloads you're going to run. Perhaps an activity or something that you have a defined date to get done, but it's not something that needs to run regularly. Perhaps the example of this might be you're calculating payroll out for the year, for the month. Well, you need to make sure it's done by the 30th of the month, for example. If you get interrupted on the 5th of the month while you're doing the calculation, it's probably not a big deal and has no impact, but you get the performance savings. So outside of this, we have one final category. I threw here into the category of purchase options, but last year at reInvent, I talked about capacity blocks and what had been happening. This gives you the opportunity to reserve capacity within the system. And last year, we talked about it just being deployed. But I've heard from many customers about a need to expand this even further. So what have we done? Customers asked us for additional functionality to introduce more features, including what we call instant capacity blocks, delivering longer duration capacity blocks, and capacity block extensions, allowing you to extend your reservation. With instant capacity blocks, you can immediately start with your GPU or machine learning workload accelerating instances in perhaps under 30 minutes. Longer duration capacity blocks allow you to reserve capacity for as long as 6 months at a time. And if you need more time to wrap up your training job, you can use more time by requesting a capacity block extension. So we continue to allow you to advance your AI capabilities by leveraging this as well. So it's pretty simple. You provide us a date window, you provide the number of instances that you want to launch, and you provide the time duration, and then you pick the location and the time on the calendar, and we provide you the capacity. This, we believe, will help save you costs as well. So moving on, I talked about large SAP workloads earlier in the talk as well. This falls in the category of high-performance computing. Today, only 1/3 of HPC workloads are in the cloud. Only 20% of HPC workloads are in the cloud, and we expect by 2028 that number to accelerate to 30%. That means the current HPC market at $37.2 billion will be expanding in the cloud here. And that means we need to support more instances and more families for our HPC customers. And did you know that Amazon has an entire HPC dedicated portfolio that we encourage you to look at? And just a few weeks ago at Supercomputing, for the 7th year in a row, we were awarded the best HPC cloud platform. But I didn't just bring up this slide. Well, I did bring up the slide to highlight how great we are with this award. But I want to call recognition here in the center to one of the new technologies that's also offered, the AWS Parallel Computing Service that we launched in August this year. So AWS Parallel Computing Service allows you, our customers, to be able to more seamlessly launch instances in the HPC space. It allows us to help you more quickly migrate your large capacity instances. It creates simplified setup for your clusters, reduces the amount of work you have to have on job management, and it helps reduce the effort to migrate over. Another great feature and way to migrate those workloads over. So we've gotten this far in the presentation and haven't said a lot yet about our new features for AI. So why not now? So in 2012, you could have been doing GPU work in the cloud, and a large instance was somebody who requested 2 GPUs, and you were putting 60 parameters or so, 60 million, parameters to do this, to do what we were calling language model then. But since then, in 2023, customers have told us that they're using 10,000 GPUs and 500 billion parameters to do this same type of tasks. But in 2024, the number is already expanded by 10x. So we're having customers request over 100,000 GPUs and nearing in on trillions of parameters. Today, at Amazon, we've been implementing machine learning for years. And we have a complete portfolio of what we offer on the instances here. In fact, every year, more than 100,000 customers build, train, and deploy machine learning workloads on Amazon. I'm showing you some of the most recent instances, and they range from the NVIDIA GPUs that Willem talked about earlier, to Gaudi Habana from Intel, to Qualcomm instances, and also our own instances, our Inferentia and Trainium instances that we've introduced. Speaking of which, we launched Trainium 2 this week, which is our latest AI chip. Our investments in Trainium 2 are helping to deliver exceptional price performance for our customers. With these purpose-built chips, we have been optimizing the architecture for deep learning workloads and helping to bring down the cost of chips and deliver effective performance. Our Trainium chips use our own generated innovations such as stochastic rounding, 4x sparsity, and we also supply floating point T-flops and other performance things to enhance the experience in using Trainium. Now, the Trainium 2 instances are actually powered by 16 Trainium 2 chips. Each of these Trainium 2 instances feature 16 of the chips that are interconnected using our own Neuron Link, which is a dedicated high bandwidth, low latency interconnect, which delivers 20.8 petaflops of compute. That makes Trainium 2 ideal for training and inference models with hundreds of billions of parameters. However, we wanted to make this even easier for customers. And in order to access these benefits, we've introduced Trainium2 Ultra servers. Ultra servers improve the reliability and enhance the security by connecting 4 Trainium2 powered instances. The instances are connected using high bandwidth and low latency neuron link, as I mentioned before. But Trainium2 Ultra server is a completely new EC2 offering, where we're extending our neuron link from connecting 16 Trainium2 chips in one instance to 64 Trainium2 chips across the instances. You can think of this as just you can think of Trainium2 Ultra servers as delivering the power of 64 Trainium2 chips in a single server. That delivers up to 83.2 petaflops in just one server, allowing you to accelerate your work. This allows customers to do billions to perhaps even trillions of parameters. That's not all in the AI space, though. As I mentioned before, with people expanding the amount of parameters that they need, they have more usage. This is where our EC2 Ultra clusters come in. Where our Ultra servers allowed you to scale up, our Ultra clusters allow you to scale out to hundreds of thousands of Trainium2 chips. Think about it. Hundreds of thousands of Ultra servers, each connected using 12.8 terabytes per second of EFA networking and linked across non-blocking network capable of transferring tens of petabits in under 10 microseconds. Recall, the rapid growth in AI compute is going to require another order of magnitude. And our final introduction in this family is we announced just this week that Trainium 3 instances are already on the horizon. So not only have we announced Trainium 2 has launched, Trainium 3 is coming as well. Our Trainium 3 instances will have twice as much compute as Trainium 2. They will use 40% less energy for the same performance, and they'll be based off of a 3-nanometer process node. So after all this, I turn that back over to everyone here in the audience, and I ask, what will you be able to build off of this? I'm excited to see what all of our customers are able to do, all of you are able to do with the new instances that we have launched here in EC2. I will offer one other note here is we covered a lot of launches in the deck today, so I decided to put a quick launch summary slide here for everybody to take a look at. These are just some of the launches that we've launched here in EC2 this year. And there are some really exciting things for everybody to look at. And to echo Willem's note, I'd like all of you to potentially, if you have not, try out our Graviton processors. You can probably get started with Graviton in under 4 hours and have an application running. And you can learn more about our Graviton sustainability efforts by taking a look at this as well. And also, for those of you that are here, they have a sustainability expo as well in Caesars Forum that if you have time between now and Friday, take a look at and walk over there as well. And if you're looking to learn anything more about the Instance Finder or the EC2 console, I will be doing a session this afternoon and tomorrow if you have an interest in getting a live demo of those two. I want to thank all of you for coming. I want to especially thank William and Ed for joining me today. And please don't forget to fill out the survey. Thank you.